linked list. In the last video, we have seen what is the linked list. So linked list is a collection of nodes, and each node consists of a data and the pointer to the next node. But in the case of a header node, we have a special type of node called the header node. So the list starts with the special type of node called the header node, and that is totally called as the header linked list. Let us see the definition. A header linked list is one more variant of the linked list. A header node is a special node that is found at the beginning of the list, and the list that contains this type of node is called the header linked list. This special node is used to store the number of nodes present in the linked list. So we can store the size of the list as the number of nodes in the header node. In other linked list variant, if you want to know the size of the linked list, we use the traversal method. Actually, what is traversal method? We have to visit all the nodes of the list. That is called as the traversal method. So each node has to be visited once. That is the traversal method. So once you visit a particular list, all the nodes, if you visit all the nodes of the particular list, we will be able to find the number of nodes in the list. So in the case of this special type of linked list called the header linked list, it is not necessary to use the traversal method because the special node contains the number of nodes present in the linked list. So that's what given here, but in the header linked list, the size of the linked list is stored in the header itself. Let us see the types of the header linked list. There are two types: grounded header linked list and the circular header linked list. Okay, so let us see one by one. What is the grounded header linked list? As the name implies, the grounded header linked list contains the last node as the null pointer. In electrical circuit, we say the ground symbol, that is the end. So for same way here, the header list which ends with the null pointer is called as an grounded because it is the end of the list is null. In this list, last node contains the null pointer. It is a list whose last node contains the null as the pointer. In the header linked list, the start pointer always points to the header node. So here, as it is the header node, the start pointer, in normal linked list, the start pointer points to the first node of the list. But in the case of the header node, the start pointer always points to the header node. So it is indicated by start arrow next is equal to null, indicates that the grounded header linked list is empty. Suppose if there is no element in the list, that means start of next will be directly null, not this, because if the element or if the list is empty, there is no nodes to mention. So directly the start will be pointed to the last null. That is the linked list, which is an empty linked list. Okay, the operations that are possible on this linked list are insertion, deletion and traversing. As any normal data structure we have seen earlier before, in any data structure we can do the insertion, add elements, we can delete, we can remove the elements, and also we can traverse means visiting all the nodes once, that is the traversal. So the same way these operations can be done in the header linked list also. Now let us see the next type of linked list, which is the circular header linked list. So here it is also in header linked list. So this part is called as a linked list. With the header, it is called as a header linked list, and if the last node is pointed to the first node, that is called as a circular linked list, since it forms a circle or a loop. The last node points to the start node, which comes to the header node. So this is called as a circular header linked list. A list in which the last node points back to the header node is called as a circular linked list. The chains do not indicate the first or the last nodes. Okay, that means the chain directly point to the header node, and then In this case, the external pointers provide a frame of reference because last node of a circular linked list does not contain the null pointer. So since the last pointer is not null, it naturally has the reference to the previous header node. That is is a frame of reference because the last node of a circular linked list does not contain the null pointer. It has the external pointers by which we can point to the some other nodes. The possible operations on this type of linked list are insertion, deletion and traversal. As usual, we can insert element anywhere, we can delete element from anywhere from the list, and also we can traverse the list. That means we can visit all the nodes of the list, that is the traversal. Let us see what is the application of the header linked list. We know that the header linked list contains the size of the list in its head. That means the head contains the number of nodes. So one application by which we are using this header linked list is the polynomial representation and polynomial operations. We all know that what is a polynomial? An equation with the powers of x is in the higher order is called as a polynomial. Okay, so here when you say it's a quadratic equation, it starts with the 2. When it is a polynomial, the equation, the degree of the x is higher. It is called as a polynomial. So the header node is used to represent the zero polynomial. Suppose the polynomial has no terms. If it is an empty polynomial, means it is denoted by the header node. Suppose if you are having this polynomial, f of x is equal to 5x power 5 minus 3x power 3 plus 2x power 2 in plus x power 1, that is x plus 10x. If this is the case, how this header linked list helps to represent the polynomial? Let us see. So from the polynomial representation of f of x, it is clear that the polynomial has two parts, coefficient and the exponent. So here in this term, phi is the coefficient and this phi is the exponent, okay, where x is the formal parameter. Hence we can say that a polynomial is a sum of terms, each of which consists of a coefficient and the exponent. So this is one term, 10 into x power 0, which is 1, and then this is x, this is 2x square, 3x3 and 5x power 5. So summing of all the terms is the polynomial sum. So each term consists of two components, coefficient and the exponent. So this particular structure of this polynomial can be reflected using the header linked list. Let us see how it is represented in that as a diagram. This is the polynomial. So as we know that the start node always points to the header node, and the header node is just pointed by 0 and -1 to say it is an starting node. And then 5x power 5. So this is the exponent, this is the coefficient, and this is the exponent. So -5 and 5. So 5x power 5. So 5 is the coefficient and this 5 is the exponent. Likewise, -3x cube. So -3 is the coefficient and 3 is the exponent. Next one, 2x square. This 2 is the coefficient and this 2 is the exponent. And same way, x power 1. Here 1 is the coefficient and x is the exponent. Okay, so and 10 x power 0. So 0 is the exponent and 10 is the coefficient of x. So this is how the circular linked list, this is the way the grounded linked list is used to denote the polynomial. So this is the way the polynomial is represented. Same way we can use one more polynomial and we can perform the addition of polynomials or subtraction of polynomials. So the polynomial operations can be performed using this representation very easily. So let us see with an example in the next videos how the polynomial addition is done and also how the circular or the grounded linked list is used for representation of polynomials and its further operations. Hope it is easy to follow, and thanks for watching.